Mr. Bay,
What?
I got like 11 hours of sleep. I went to sleep last night by 9, and I was like, yo, I'm not going to wake up. What should I? And then it turns out they had a beer. I was like, so I got like so much hours of sleep.
Yeah, dude, I slept past my alarm, so if we didn't have a delay, I would have made this one.
We didn't have a delay. I probably would have.
Okay, questions 10, 11, 17, 18 from 2.6. And then there's, I don't know what numbers they were, but there were some similar questions in 2.6 day 2, which is not due until tomorrow, of how to do these problems, okay? And here's the thing. We're going to come across a lot of different relationships in this course in which we set up equations, okay? But then when we set that equation up, we have to look and analyze that equation and think, okay, is there one variable? There's one variable that's kind of like 7th, 8th grade math. We solved those for a long time. If there's two variables, we learned a technique last year, Mrs. Foles, and Mr. Herr's class, Mr. Boyd's class, on how to do that. Okay? Yep, she right there? Okay. And there's going to be maybe at some point where we get like square roots in our equation. However, and when we create an equation, directions don't come with it in words. It doesn't say, hey, this is an equation with two variables. Remember, this is how you do them. Okay? You have to be able to recognize the makeup of the equation and realize then what you do with that specific type of makeup. Okay? And in this case, this is referred to as systems of equations. Okay? Which you spent probably 5, 6, 7 weeks last year talking solely about systems and equations. Okay? You guys remember taking two lines and graphing them and seeing where they cross?
Yeah.
Okay, that's systems of equations. That's what we're doing. We're not doing the graphical part, and we're doing the analytical part, the algebra part by hand, but we gain the same information.
Last night, I didn't do this problem because I was going to ask you about it. Because just like that one, but on the very left one, it's angle 1, and on the top one's angle 2, and the right one's angle 3. And it says angle 1 equals 3x, angle 2 equals y, angle 3 equals 87. And I found x because it said 87 divided by 3, and that's x. So that means 1 and 3 are equal to 29. So to find out y, do I have to take 180 minus 23?
The sounds of it, I think so. They give that wrong to you? I'll look at yours individually in a moment. This problem here, when you come across geometry, hopefully you recognize the relationships. Okay? What argument can you tell me about those two things? Okay, I'm going to say 5y plus 2x equals 180, right? Okay. Now the reason this question or this equation is problematic is because it has two variables, right? And you could go through some work here to solve for x maybe. I'm just going to do this real quick. We can say that x ends up being, we'll get 90 and then negative 5 halves y plus 90. Just isolate x and solve for x. But that really doesn't give us anything because I still have y in the equation. Does that make sense? So what we call that is we solve for x in terms of y. We want to solve for x so we just have a numerical quantity on the right-hand side and not an expression like that is. Okay? So, what happens when we get an equation with two variables? We will always have that situation where I can solve for a variable, but it's always going to have the other variable in the other side of the equation. So, what we need to do is recognize another relationship. And my hope is that you see that that is another relationship, right? What can you say about those two things? Okay, add them together equal 180. So 2x plus x gives me 3x's plus y plus 92 is equal to 180, right? So now we got a second equation. Okay? And to be honest with you, that's really all we need to solve this for x and y. There will be situations where maybe it's a little bit simpler to still look and recognize if there are any other relationships that we know to be true. And if I look at what's going on up there, you know that blue angle and that blue angle are the same. another relationship, right? They're vertical angles. So the vertical angles were congruent, so their measurements were equal. So we're going to say 5y equals x plus y plus 92. Okay? So we get three equations, and they're all true. We get that equation, that one, and that one, just numbers, so they're easy to talk about. But every one of those equations is true because we gained it from a geometric concept. Okay? Whether it was linear pairs or vertical angles, we know those three equations are all true. Do they all use the same variables x and y? Yeah, and that's nice, okay? And I think this was like question 11 from Math Excel. But if you look at question 10 was a little bit easier. I can give you a picture here. This is question 10. If I go through question 10, maybe I do the same thing. Are those going to be supplementary?
Yeah.
So 3x plus y equals 180, right? There's one equation. Are these two going to be equal? So I say 2x equals 2y minus x. Okay, so that's a second equation. What about those two? Supplementary. Well, what's 2y plus y is 3y, right? Add those together. What happens when I add x and negative x together? They cancel out and it gives me 180, right? Of those three equations, is one of them able to be solved easily? You solve y easy, right? In that last one, okay, y will be 60. Well, if y is 60, in that equation, because that y is that y, okay, it's the same throughout all of these equations. That can be replaced with 60, that can be replaced with 60, and now we have equations that can solve just that x, right? The reason I go back to this question is because when we start setting up equations, okay, and relationships, I want you to realize that it's probably a good idea to write down as many relationships as you know to be true. Because if I were just to do equation 1 and equation 2, there potentially could be an equation 3 out there that might allow me to solve the problem a lot easier than the technique we actually would have to use here with 1 and 2. Does that make sense? You know, we're going to go through, we're going to solve this system using these equations here. But I could have done the same thing here. The procedure with that, using just those two equations, is pretty long and complex. Okay? It might take 5-7 minutes to do this problem with those two equations. But if I recognize that this relationship was out there, it might only take me a minute, 2 minutes to do the problem. Does that make sense? Okay? So I want you guys to realize that as we're doing things, do not be robotic. Do not just start doing stuff and have no thought behind it. Okay? Because you're going to waste a lot of time. Especially when you get like the ACT, and of course, again, those things are timed, right? ACT, 60 minutes, 60 questions. Okay? Well, if I spend 6 minutes for the first question, I'm behind the 8 ball already. Okay? You want to be able to think about all the different techniques and all the different routes you can take. Pick the one that's the quickest, most efficient, so you can start to bank some time. So at the end of the test, when the questions are hard, you have maybe 15-20 minutes to do 2 or 3 questions. This is how we approach these problems, though. If in an example or a homework question, you get to a situation where none of your relationships were able to be solved down for x or y individually, you then have to start taking 2 of these equations and pairing them up. And it doesn't matter which 2. I'm just going to take the first 2. I think that's probably going to be as easy as taking the last 2 or the first and last one. It doesn't really matter. But we're going to take the first one, 5y plus 2x equals 180. Okay? And then I can pair that up with either equation 2 or equation 3. It does not matter. I'm going to pair it up with equation 2. But I'm going to rewrite equation 2. Okay? I'm going to rewrite it so that the y comes first. Okay? So that y is a positive y. So I'm going to write that as, I'll do it in green still, positive y here. Okay? Then I've got my 3x that comes after that. So I'm going to go, it's a positive 3x, so I'll go plus 3x. So just using my associative property of addition to move things around here. And now this 92, I don't like it being on the left-hand side. I'm going to move it over to that side. Okay, so when I subtract those, I should get 88. Okay, so what I have written here in green is a variation of that first green equation. It does the same thing, produces the same results. It's just a better format right now for what we want to do. Good question.
I got another question. I saw for X, but
Okay, well, hold on. Let's talk about this, and then hopefully what we get through here will lead you to what you're going to. When we look at this, the task is, and this is the reason we wrote things this way, we want to get our equations written so you have a column of y's, you have a column of x's, and you have a column of what we call our constant values. Okay, things that are non-variable. Okay, they're always 180 and always 88. Okay, they don't change. And the hope is that when we add straight down, my y's end up adding to give me 0, or my x's add up to give me 0. And if I look at them the way they are, if I add 5y and 1y, what do I get? If I take 5y plus my 1y, add straight down in the yellow stuff, what do I get? 6y. What do I get if I add my x's? 5x. The goal was, the hope was that one of those coefficients, either the 6 or the 5, would have actually been a 0. Okay? So that tells us, because that doesn't happen here, it tells us we have to alter things a little bit. We have to change one or both of these equations. What we want is that the coefficients of either your y's or your x's end up being opposite one another. Okay? So I either take the 5, okay, and I'm going to force it to stay a 5, and I want to make this turn into a negative 5. Does that make sense? Okay. Maybe sometimes last year you would saw, maybe I want to change my x's. There's no way, there is, but it's through using fractions. I don't want. It's really hard to take a 2 and change it into a 3, or vice versa. Okay, I want to take a 3 and change it to a 2. I have to multiply it by 2 first, okay, and that's multiplied by fractions. It's kind of hard. So if I wanted my x's to disappear, I'd probably have to change that to a 6x and that to a 6x. Does that make sense? You guys remember doing that kind of stuff? Okay. I think changing the y's is going to be easier. And what we need to do is we need to realize that we can multiply by anything that we want to, as long as we multiply every part of the equation by that anything. Okay? So I'm going to take that negative 5, and I'm going to distribute that to all 3 parts of it. So it's going to be negative 5y. Okay? Give me negative 15x. Okay? And now 88 times 5. Well, 8 times 5 is 40, right? Okay? So negative 440. Okay? The top equation we didn't multiply this by anything. We didn't change that at all. So we're just going to basically cut and paste it and put it over here. Alright, now the hope is, if we've done this correctly, now when I add my columns straight down, when I add those 2 numbers straight down, what's it give you? 0. Okay? That's nice. I mean, we've just eliminated a variable. When I add my x's straight down, what do I get? Negative 13x. Okay? And now adding my constant straight down, okay? 180 minus 440 is a negative 260. Okay. Do I now have negative 13x equals negative 260? A pretty easy equation to solve. Yeah. Divide both sides by negative 13. And x ends up being 20. So solve for x. I think where your question was, you solve for x, and now what do? So I need y as well. Okay? Well, what that means, once I have that x, that means that everywhere in any equation that I have developed throughout the entire problem, and we've got a lot. We've got the first original 3, and then we've got this one here, this new one here that we developed, right, through multiplication. So we actually got 4 equations we can actually plug this x back into, and it will work. Okay? But what it means is that ultimately that x right there is now 20. That x is 20. That x there is 20. And that x there is 20. Okay? So I'm going to go back into that first equation. We'll plug into that. And I just think it's going to be maybe a little bit easier to do that one. So I go 5y plus then 2 times x is now 20 equals 180. So 5y plus 40 is 180. 5y is equal to 140. Y then ends up being 28. Okay, so x is 20, y is 28. When we come back up here, x was 20. I'm just going to check myself to see if these solutions make sense in regards to these original pictures. If I have 5 times y, so 5 times 28, that gives me 140. If I have 2 times 20, that gives me 40. If I have 20 plus 28, it's 48, plus 92 is 140. Are these two things still supplementary? And that's what we started off with, right? We said they had to be supplementary. That was the equation we developed. Now with those specific values of 20 and 28, we do see that relationship exists. Are those two angles supplementary? Yeah. Are these two angles, that one there and that one there, are they congruent? Okay, they're both 140, aren't they? Now, if I would have gone through the math, then I would have gotten like x to be 19 and y to be whatever. Okay? And I plug back in, I will not get the relationships of 180 and a relationship of congruency with those parts. Does that make sense? So once you have your x's and y's, plug back in to make sure that the preconceived notions that you had, and ideas that you had about the problem, do still exist. And that can verify and tell you that you've done all your algebra right. Okay? You could do the exact same procedure using the green equation and the blue equation. Okay? It will still get you x to be 20 and y to be 28. You can do the exact same procedure with the purple equation and the blue equation. You do the exact same. Huh? 5y equals 180. Where are you seeing that at? Oh, so you can do. If I do these two. Okay, so that's 3x. So you could have done 3x plus y equals 88. And you could have done, it's going to be negative x plus 4y equals 92. I got to move that x over, got to move that y over. Okay? But I should be able to maybe multiply everything by 3 here, get my x's to cancel out, solve for y, and y would be 28 again. That's a great. And then I can plug back in x to be negative or x to be positive. There's going to be, so I sent you a video. Okay. Guys, remember when you guys sign up for classes, they do that paper, you got to have the teacher sign off on it. They sign off on it because they're assuming, they're saying that you've done enough to be successful in that next class that uses a lot of the information that you learned in the current class. Okay. Now I know that's kind of a bad assumption to take. Okay. So if you know that we're working with system equations, you know that what we just did you were not very good at. Come to my website, scroll all the way to the bottom. Okay? I'm kind of zoom down here. Right here it says system equations. Click on it. There are a lot of lectures here and probably hundreds of examples that teach you how to do system equations. Okay? No, it's not me. But it removes the geometry and allows you to focus on that algebra. Does that make sense? Geometry is not that hard. Would you agree with that? Taking these angles and saying that they're supplementary and saying that these ones are equal was not that hard, right? It's when we develop algebra that we don't know what to do. Okay? We're also going to, at some point this year, do a lot of factoring. If you suck at factoring, you know it was something you struggle with last year. So right here, takes you all this extra work, and all this extra videos for factoring. Okay? But what has to happen In order for you to get good at this stuff, you have to have what?
Practice.
You have to have practice. You have to have a desire to go. You want to be good? Go to the videos, watch the videos, learn the stuff again. Okay. I cannot teach you algebra in one class and geometry in the same class. That makes sense? It's impossible. I don't have time to do that. Okay. You get to a science class and you say, well, he's not teaching me how to use Avogadro's numbers, conversions, and stuff like that. He shouldn't have to teach you. Those are 6th and 7th grade standards. Okay? You have prerequisites for courses, and it's important that you remember them. Okay? Now, if you don't remember them, okay, I understand. But now take this, use it as a learning experience. What do you think's going to happen when you get to next year's math class? What do you think you're going to need from it? Geometry. So don't make the same mistake maybe you made when you were in Algebra 1. Okay? And then when you get to Algebra 2, guess what? That information is going to be vital for you to be successful in the next course. Please take initiatives to retain information.
I thought next year was how we ever do it.
It is.
I'll keep that. Reading my way. Shut up, please. Thank you, Father.